Find the values of m for which the line y equals mx minus 2 and the curve y equals m plus 1x squared plus 8x plus 1 do not intersect. So the first thing is to solve these simultaneously. They both say y equals, so I can put the right-hand sides equal to each other. So I have m plus 1 x squared plus 8x plus 1 is equal to mx minus 2. Now, subtract mx from both sides, and we get m plus 1 x squared plus 8 minus m x, and add 2 to both sides gives us plus 3, is equal to 0. Now, if we're looking for the number of roots, we know that we can use the discriminant b squared minus 4ac. And in the case of wanting them not to intersect, that means we want no roots, and therefore we'll be looking for that to be less than 0. So, we will get 8 minus m squared, take away 4 times m plus 1 times 3 is less than 0. Or 8 minus m all squared, take away 12, m plus 1 being less than 0. So expanding the 8 minus m all squared, which remember is 8 minus m, and then use a crab claw, that's going to be 64 minus 16m plus m squared minus 12m minus 12 is less than 0, and tidying that gives me m squared minus 28m plus 52 is less than 0. Now, what we can do there is consider m squared minus 28m plus 52 is equal to 0. We can factorize this quadratic. It becomes m minus 26 and m minus 2. Now, if we consider y equals that, that is going to be a parabola with a minimum. It's going to be happy because the coefficient of m squared is positive. So what that's going to look like is it's going to come down and up like that with the x-intercepts at 2 and 26, because from here m minus 26, m minus 2 is 0, we get m is 2 or 26. Now we're after where it's less than 0, in other words, where it's below the axis. It's below the axis between these two values. So we can see it's below the axis here, and therefore m is between 2 and 26.